In this session, let us learn computational problem solving. Here, we will discuss what is a problem, what are computational problems, developing solutions for these problems, and its representation. We face problems in various fields like telecommunication, microbiology, logistics, fields of engineering, healthcare, energy sector, etc. We have problems everywhere. So what exactly is a problem? Problem is an obstacle, difficulty or challenge, or any situation that invites resolution. Problem solving is an intellectual process that involves identifying the problem, analyzing, and then solving it. This requires logic. Now, let us see what is a computational problem. Computation involves a series of states. Transition from one state to another results in solving the problem. The different types of computational problems are decision problems, where the answer for every instance is either yes or no. Searching and sorting problems, which involves searching an element from a given set of elements or arranging them in an order. Counting problems, which involves counting the number of occurrences of a type of element in a set of elements. And optimization problems, which involves finding the best solution out of the several feasible solutions. To solve a problem, first we must understand the given problem. Then we develop a suitable logic, followed by implementing it and verifying the solution. Logic is a method of reasoning, and it requires thinking in a step-by-step manner. We need to represent the logic in some form. We use algorithms to represent the logic. An algorithm is a step-by-step procedure to solve problems. The various properties of an algorithm are: it must be finite. That is, it must terminate after a finite number of steps. It must be definite. That is, action carried out in each step must be unambiguously defined. 0 or more inputs should be provided to it initially or dynamically. It must have one or more outputs. It must be effective, that is, operations must all be sufficiently basic. Algorithm can be depicted diagrammatically using flowcharts or natural language using pseudocode. More details on algorithm will be discussed in other videos. Having got introduced to algorithms, its properties and representations, let us discuss the various algorithm design techniques such as the brute force, the greedy approach, the divide and conquer, and the dynamic programming. We shall discuss these techniques one by one. The brute force technique involves trying out all possible values or combinations to solve a problem. For example, trying out all combinations to open a safe, or trying out different passwords to hack into somebody's account, or trying out different combination of numbers to open a lock. The greedy approach is used in optimization problems. Here, we break the problem into different steps. Solving each step results in partial solution. These partial solutions can be extended progressively to obtain the complete solution. A classic example of this is the traveling salesman problem. The problem here is to find out the shortest possible route by which the salesman can travel to all the cities A to F, such that he does not visit a city more than once. In the divide and conquer technique, we recursively break down the problem into subproblems, each of which is independent of each other. The solution to these subproblems are combined to obtain the final solution. For example, a problem is divided into independent subproblems and each task is assigned to a person. Then each person is applying logic and find the independent solutions, which will then be combined to obtain the final solution. Dynamic programming is a design technique which is used to solve problems with overlapping subproblems. The subproblems here are dependent on each other. For example, consider this Fibonacci series. Here, the first two elements are seed values. To obtain the third element, we must perform the addition on the seed elements. Similarly, to obtain the fourth element, we must add the preceding two elements, that is, the second and the third element, and so on. Thus, each step here is dependent on values obtained in the previous two steps. Let us revisit what we have discussed so far. Computational problem, algorithms, properties of algorithms, algorithm design techniques. For hands-on practice, please do the exercises provided in the lab guide under the computational problem solving topic. This will help you understand the implementation aspects.